I just want to, like I said in the previous class, give out a few examples that already exist in the class text of how we implement some of the data manipulation instructions. If you remember correctly, in the previous class, we had indicated that we have two types of data manipulation instructions. And we said that one of those is called is the input, and the other set for those of when we were finishing the class, I think we were looking at the arithmetic operations where we were doing data comparison. We say that data comparison are input instructions. And then when we were looking at the initial stages where we were looking at things like move and must move, we say that those are basically outputs. They are output instructions. So it was important for us to classify them like that so that we look at their implementation today. So I just want to quickly look at some of the diagrams, explain them, see how they work, and then we end data manipulation instructions today so that from Monday, we do our last topic, which is program control instructions. So, oh, I didn't share my screen. Okay. Okay. So we want to look at just quickly look at some of the examples that are provided, see if they make sense and if there are any issues, because they should be very direct, actually. Now, the one thing that I constantly want to remind you is that we had what we were calling data manipulation instructions. So this is where the chances of mistakes, we had two types. We had data comparison, and then there's, I don't know, we're calling it data what? Somebody to remind me, please. The move and the must move instructions are called, is it data transfer? Right? So the ones that we are interested in data comparisons were the arithmetic operations where you had things like equal, greater than, less than, the limits, and so on. But my point here is the transfer instructions where we had the move and the must move. These ones were very important. They were output instructions. But these ones are input instructions because that forms how we construct the ladder diagram. That was very important. Okay. Sorry. So I think let me continue. So now we want to look at just some examples and see how these data manipulation instructions are implemented using logic diagrams. And you'll notice that in most cases, they're never really implemented on their own. We include, because the applications that we want to solve are usually very, very robust. So they are not just restricted to, maybe data manipulation. They always involve other things happening. So we always include timers and counters as well in our ladder diagrams. So usually our ladder diagrams are very, very inclusive. So that's exactly what I want us to quickly look at in the next few minutes, and then I'll provide you with the takeaways CAT, and we end it here. So the first one is a very simple ladder diagram as well, but it's a very good illustration of how we use the move instruction. Now, what is happening in this case, because I told you one of the key things is even if you're given a ladder diagram, it's important to scan through it and quickly understand what happens. And you will see that if you already know how each of these components and the modules that we have work, then it becomes a very, very easy thing to decipher. Anyway, so in the case that we have here, we want a scenario where you have a timer, but you're using a move instruction to create what we're calling a variable preset values. Usually when we have a timer, we always fix this value here. This value here is always fixed. So we fix that value. But because we have move instructions, we don't have to fix the value. We can leave it to be variable, so it can keep changing, so that we can use our timer in different scenarios. You see, if we use it when it is fixed, then we must have a timer for maybe 10 seconds. We need another timer for 30 seconds. We need another timer to be preset at 40 seconds. But when we have move instructions, then we can let our timer preset value be variable, so you can keep changing it. Now, one of the key things to remember here, you can see that when we are leaving it as variable, then this value here is set at 0 because it can change anytime. Usually or typically, we set the preset value before we even energize our timer. The preset value is set. But here, we leave it as 0 because it can vary based on the subsequent ranks where we are using our move instructions. Now, in this case, you can see that we have a situation that's very simple. If you look at the inputs, the field devices, there's a push button and then there's a selector switch. So here, where you've got your push button, clearly you can see that that push button is translated to the input for the timer. So it is the one that energizes the on delay timer. It's the one that energizes or activates the on delay timer. Whereas the selector switch, you can see here, and it's even illustrated here so that you've seen this kind of switches, the one we are calling a selector switch. You can see that the selector switch allows you to select a certain direction or select, in this case, there are two, you can operate it in two positions. You can select the 5-second position or the 10-second position based on how you twist this timer. So because you are able to set variable positions, then we can use that to allow us to have variable preset values for the timer. So basically what we want to achieve, if you look at the output, is we have a pilot lamp. And the idea here is we want this lamp to be turning on and off at certain preset values. But we don't want to use several timers. We just want to use one timer, but we are able to control the intervals for the pilot lamp to turn on and off. And so the move instruction becomes very handy in helping us achieve that when we have only one on delay timer. So you can clearly see, if we follow the ranks clearly from left to right, top to bottom, if the push button is pressed, then we'll definitely have a logic 1. If we have a logic 1, then we energize the timer, the on delay timer. Now, typically, when you energize the on delay timer, you expect that the timer starts timing because there's a clock within the timer that starts counting. So we expect it to start timing. But typically the timer is supposed to start counting based on the preset value. But our preset value for this case is 0. We've not set it. We've left it to be variable because we want the done bit to be equal to 1 when the preset value equals the accumulated value. But here the preset value is still 0. So that is where we use the move instruction. So it means that when I press the push button, PB1, then the timer will be energized or it will be activated using a different terminology. However, it will not start counting. Why? Because the preset value is 0. It has not been set to a certain value for which it is supposed to count or for which it's supposed to time. So it will not work. However, if you move to the second rung, you're now expected to either select, because you first press the push button, and then you either have to select the 5 seconds. You can see we have the 5-second position or the 10-second position. So if you select the 5-second position, then you can see that we have 2 move instructions here, and they're very critical in the way they have been set up. We said that move instructions are output instructions. So you can see they are put on the right of the diagram. They are on the right of our ladder diagram, the right side of our ladder diagram, because they are output instructions. Now, because they are output instructions, we say that all we need after labeling them and providing an address for them is to either give them a source and a destination. So you can see that the first move instruction, this one, has been given 10. So the value 10 has been put in its source address. So the source address here is N71, just like we were looking at it in the previous class. So if the source is N71, in that memory location, the value 10 has been stored there. Now the destination you see has been given as T41, meaning they are referring to the timer and they are referring to a very specific location, which is the preset value. So it means that this value 10, is supposed to be sent or is destined for the timer, but the preset location. So the preset at that point is 0. You can see that the destination currently is reading 0. But the idea is, if we activate the move output instruction, then the value 10 needs to be transferred to the destination of the timer, especially on the preset value. The second one, again, the same thing. It's been given the 5-second option. So notice this was N71, this is N72. So we have a different address with a different value, but still destined to the same timer address with the same position of the preset. So this 5 value, meaning if we activate the second move instruction, then a value of 5 is then transferred or is moved to the timer preset value. Okay, so then now we can understand how this works. So we first press the push button, we energize the on delay timer, nothing happens. We then select either 5 seconds or 10 seconds. If we select 5 seconds, for example, then you will see that this SS1 will be logic 1. Assume we have selected 5 seconds. So let me just remove this part. So we have selected 5 seconds. Remember, the timer is already active. It's already energized. But because we have selected using the selector switch, we've selected 5 seconds. It's in the 5-second position. Then it is the rung 3 that's activated, because it's rung 3 that has the move instruction for 5. So rung 3 would be activated. And when rung 3 is activated, what happens is it will then move the contents of the source to the destination. And therefore, this value of 5 will be moved to the destination. Apparently, that destination is the destination of the timer, which is 5. The preset value for the timer will then become 5. Now, notice at that exact same time, because this is value 1, we have activated this as 1. This is a normally closed contact. So it means that this will be a value 0. The logic value there will be 0. So the move instruction for the first move instruction in rung 2 will not be activated. The reason is because we have the normally closed contact there, so that we can only activate one move instruction at a time. So then once we have moved the value from 5 into the timer preset value, this becomes 5. And because the timer was already active, the clock was just waiting to be given the interval of count. It will automatically start counting. And the moment the preset value, we say that when the preset value equals the accumulated value, then the output, so you can see, check here, the done bit here will be 1. The moment the preset value equals the accumulated value, meaning the moment this guy gets to 5, then the done bit equals to 1. So we are using that done bit as an input here. It is equal to 1. It's the one that then now energizes the lamp. So the lamp turns on because we have set the value of the timer to 5. Because it was active, the timer was able to count to 5. The done bit came to logic 1, and then that activated the pilot lamp. So 5 seconds later, the pilot lamp will go on. Okay? On the other hand, if we decide to press the push button, but now we have set the value to 10. So the timer, the selector switch is now put in the position of 10. So now it means we need a 10-second delay period before the pilot lamp is energized. So this is for 10 seconds. So if we put it on the 10-second position, then now rung number 2 is the one that will have a logic continuity, and rung number 3 will not. So in this case, this is the guy that will now have a logic continuity, and this is the guy that will now this is let me, when I say this is, maybe you not see. So we want this to be now logic 1 and this one to be logic 0. Okay? Now you might ask, how can that be achieved? Because you see, this is a normally closed contact. We know that if you have a normally closed contact, all I need to do is give it a logic 0, and then it will pass logic. So then, and then of course, because it's a logic 0 given on the selector switch, then this becomes 0. Okay? So that is very simple. You can see in the way you can select here. These ones are like, you have a position for 0 volts and you have a position for 5 volts, something like that. So when you're putting the selector switch on the 0 volt position, that's the logic, then now you're transferring it to this part. When you put it on the 5 volts position, then now you're transferring it to the 5-second part. So that is how, when you are an engineer, you now set the instruction here at the selector switch, such that when you can even put it that when it's in the off position, then it is rung number 2 that is activated, because that's equivalent to the 10 seconds. But when it is in the on position, the 5 volt position, then now that's like equivalent of logic 1. So that now activates rung number 3. Okay? That is how selector switches work, so that you're able to vary. You can use the 2 positions of the switch to be able to give you an output. So the first position can be the off position, the second position can be the on position, but each one of them will provide you with an appropriate output. So in this case, like I said, the off position, when it's in the position like you see it is, then it's like you're providing a logic 0. And now when you provide a logic 0 here, when you provide a logic 0 to a normally closed contact, the output is a logic 1. But remember, you're providing a logic 0. So for a normally open contact, the output is still a logic 0. So that means that this guy will not work, but this is the guy that will now work, so that this value is now transferred to the preset value, which is 10 seconds. This guy becomes 10 seconds, and then it starts counting. And when this value reaches 10, then we have the done bit going to logic 1. When the done bit goes to logic 1, the pilot lamp is of course energized, and then it goes on after 10 seconds. So you can actually see that in this case here, we are using one timer, but we are able to achieve two different preset values based on a selection. So we only included a selector switch so that we are able to either vary between 10 or 5 seconds based on what we want. Okay, so that's a typical use of the move instruction. Remember, I told you when we say we are moving, the source address still retains the information, but the destination address is overwritten. So you overwrite the destination, but the source address still contains that information. That's usually very important. So that's one way of using the move instruction with a timer. There's another one here. Again, I told you today, I just want to look at these examples and explain them before I instruct you on the CAT, and then we end it there. So you can see another one here. We're just looking at the diagram, and then we envision how probably it works. Now, because usually these diagrams are clearly illustrated and you can see. So now here I can see that we have switches A, B, and C. So you've got these switches here, which you can attest to are physical devices. These are field devices that you can actually press. Now, I can see a motor and a conveyor belt. So here, again, we are using move instructions because I can see the switch A has a move instruction on the output. Switch B has a move instruction on the output. Switch C also has a move instruction on the output. But the first instance is we have a counter. So we are counting products, or because I see a conveyor here. So every time like we said, this is an up counter. So it means that we are counting products as they pass along the conveyor. But again, notice what has been done to the preset value. It's 0. So it's not preset. They've not set, because we normally expect that we say maybe 20, so that it counts 20 products, and then maybe the pilot lamp that shows that it is full. So maybe if a crate of products, or maybe a crate of loaves contains, a crate contains 20 loaves. So we need to count 20, and then the lamp goes on to show us that batch is full, or that crate is already full. Now I see a limit switch. There's a limit switch here. So this limit switch is the one that is connected to the counter. So notice, if you press the limit switch, then the counter is energized. But the counter cannot start counting because there's no preset value. Because usually these counters and even timers work on the comparison between the preset value and the accumulated value, meaning that you're starting to count from 0, but the preset value is what you want to achieve. So if you've not been given a target, there's no value preset to target, then there's no need to start counting. So then it means that once the limit switch is engaged, then you have to engage either the switch A, switch B, or switch C. And of course, lastly, I see there's a reset, which is just to take back the accumulated value to 0. Remember, for counters, you need to reset. For timers, remember, the on delay timer and the off delay timer do not need to be reset. We reset the retentive timer, because when you switch off or you you de-energize a timer, then the accumulated value automatically goes back to 0, because it does not remember what count it was on. But counters, their value will stick. So you'll need to reset it to take it back to 0. So that's why we have a reset button for the counter here. Don't forget that. Now, if we had a retentive counter, a retentive timer, sorry, if we had a retentive timer, then we'd also need a reset button. But anyway, we have a case here where you have 3 move instructions, each with their own switches. So what happens in this case, clearly, you can see that you first energize your counter. You energize the counter as usual, so you give it a logic 1 as usual. But because there is no preset value, it's waiting for a move instruction to give it a preset value. So if I select switch A, for example, that means if I engage switch A, then there's going to be a move instruction. You can see N71, the contents of N71 will be moved to a destination, which is the counter preset value. You can see it's a counter C51 preset value. So this counter preset value will be given 300. And as soon as it gets 300, it means we need to count 300 of these products before the lamp is energized. So as soon as we engage switch A, then this move instruction is executed. And as soon as the move instruction is executed, because the counter was already energized, it starts counting. So it will count up to 300. And the moment the accumulated value has reached 300, of course, the done bit goes to logic 1. When the done bit goes to logic 1, you see that is the done bit we have here. And of course, therefore, it then engages us to the pilot, the lamp that shows us that the count or the batch is full. So that is engaged. Alternatively, if I press B switch, if I press the second switch, okay, so now we leave the first one. You press the second switch, then now you have a value of 175. So this is changed to 175. And this is now what you start counting again. Again, if you use switch C, then now we'll be counting 50. So here, it's like you have maybe different products that are packed in different batches. One is packed in batches of 300, another one is packed in batches of 175, another one is packed in batches of 50. So you can use one PLC ladder diagram to be able to control the different batches. So now, if you were to do this without move instructions, you will need counters, 3 different counters, each having its own preset value. And then you'll have to organize how each one of them is activated while the others are deactivated, because you only need one counter to be working at a time. So in this case, therefore, you only need one counter, but now you can use 3 move instructions to help you so that you don't. So these are cases where even if you didn't find 3 counters, but you want to achieve 3 different counts for different batches, then you only buy one counter, but then you get the move instructions, because the move instructions will enable you to have a variable preset value. So again, here we're achieving a variable preset value for the counter. So it can either be 300, 175, or 50, based on which switch is selected here. So once you are done with that batch, you can always reset. When you reset, the accumulated value goes back to 0. That's why reset means you just make this logic 1. Then you see it's reset C51. Resetting meaning it takes back the accumulated value to 0. Okay? So now the other thing to remember here is that only one move instruction occurs at a time. So assume somebody in their own folly decides to press switch A and switch B. You decide that you have pressed both switches at the same time. You remember you only have one counter. And so when you have one counter, it means that you can only preset one value. You cannot preset 2 values. So if for any reason somebody presses both switches on, the PLC is wired such that it is going to take the last instruction that was given. So if I pressed switch A and then immediately pressed switch B, then the PLC will energize or activate the second move and ignore the first move. Okay? So the last instruction given, because remember these are input instructions, the last input instruction is the one that is executed. So in this case, even if I pressed all the switches, it is the order in which I pressed them. The last one that was pressed is the one that is going to be executed. Because in this setup here, we only have one counter. And so we cannot allow 3 different output instructions to work at the same time. Because you can't set the preset value to 300 and 175 at the same time. Only one needs to be set at the same time. And so if for any reason somebody engages more than one switch, then the last switch that was engaged is the one that is active. is the one that is considered to be active, or it's the one that will be energized. The other one would be ignored. That way, we ensure that we only provide one output instruction to preset the value of the counter. Okay, that is a very, very important point to remember. Okay, so again, this is a very, very simple setup, but it's really practical. So this is a company where probably they only have one conveyor belt. Okay, at one point they are packing pallets, and those, maybe in one pallet they need products that are 300 quantities of 300. Then at another time they need products in quantities of 175. Maybe now the wholesalers, retailers, and then they need products in batches or in packs of 50 now for the lower consumers. So they can pack for each set, but now based on the switch that they select. So somebody, only the limit switch is just to engage the counter. But then when they engage the first switch A, then they'll be packing these products in batches of 300. And then the lamp will the lamp will energize to show that the packing or the process is the crate or whatever, the pallet is full. And then when you engage the second switch, then now they do a packing of 175. When you do the C switch, then now it will be packing in 50. So you can imagine if the first operator came in and engaged the first switch, and he was in charge of packing products in groups of 300, then he'll engage his first switch and do his job. But if a second guy comes in and engages, because he's in charge of packing them in groups of 175, he engages the B switch without even having to check the status of the A switch, then you see it will still work, because the last instruction that's provided is engaging the B switch. So it is only this guy that would be engaged, and the other instructions will be ignored. Okay, so even if another guy comes in during his shift and without looking at whatever happens on the others, he only comes and engages the C switch, then for him it's just going to work, because it's only that last instruction that will be engaged, and that is what will work for the rest of the production, but the others will be ignored. So because in the company, you might not see them writing here A, B, or C. You'll just see that here they'll indicate, okay, practically they'll just put this, they'll have these switches here, A, B, and C, but they won't write them as A, B, and C. Here, they might even put a tag and indicate that this is for 300, this is for 175, and this is for 50. Okay, so the guy who is working to pack them in 300 will only come and press his switch and ignore the others. Then the guy who comes and presses the 175, again, just presses that to engage his pack of 175. And he doesn't have to bother about the position of the other switches. But the PLC is wired such that the last instruction or at the input is the one that is considered. So then it will still work. Unlike if they were to work simultaneously, then it would cause a major problem. There would be a serious confusion in the scan cycle, and so maybe the process would not even work properly. All right, I think I need to move on. So at least we've seen how move instructions can be used either with counters or with timers. Okay. Now I need to look at another. Now I know I provided you with some notes already, and so you should look at them. There are certain other. I told you this in the previous class, that there are certain other data manipulation instructions that exist, but they're unique to certain manufacturers. So, for example, this file-to-file copy, we have this exists in quite a number of manufacturers. Okay, so file-to-file copy, meaning each file corresponds to the other file. So whatever content is in 528 is copied to the other file at the destination. Okay, so these are easy to understand. I don't have a problem with. They're very, very simple instructions. What I want to look at is the compare. We had talked about the data compare instructions, and we had said for the data comparison instructions, these ones, remember, they are output instructions. Output instructions, meaning sorry, data comparison instructions are input. The one we've just done with here are the output. Sorry, the move, the must move, those ones are the outputs because you can see they were put on the right hand side. But now the comparison, the data comparisons are inputs. So you will always notice that whenever we are having the output instructions, there must be a set of inputs that come along with them. But now you will see that now we are moving to input instructions, the comparisons. We'll need outputs to be to accompany each one of them. Okay, so let's see if that is true. Sorry for the scrolling. I just need to get to a typical ladder diagram, and then we get to understand it. Yes, there's one here. There's one here. There's one very nice one here, which at least has more than one comparison. Aha. So now here they also have a counter. Again, this is a very, very simple process. Now you can see that because data comparisons are input instructions, so you can see that they exist at the input and they must have an equivalent output, or they must have an output coil that follows them. Okay, so please don't forget that when you are also drawing, because you'll be drawing this on your own. So don't forget, sometimes you need to understand that the module you're drawing requires to be an input, others require to be an output. Let's try and understand this one, and then we finish the class, because again, this is just the data comparison. There's less than, equal to, greater than. The one that I don't see here is maybe the limits. We'll check one if there's one for limits. But again, it's a very, very simple instruction. If you look at this instruction, always start with what is at the input and what is at the output. The inputs, you can see that it's just a counter input. We only have a counter input. And because it's a counter, we need to reset it, meaning we need to take the value back to zero. The accumulated value at some point needs to go back to zero because it's a counter. So because we have, does somebody want to ask a question? All right, just ensure your microphones are muted. All right, so because we want to engage a counter, but you can actually see, so we have just one switch for engaging the counter, and of course the other one for resetting the counter, right? So this is easy to understand. That's okay. Now let's move to the output. You can see that we have three different lamps at the output. One is labeled the less output, one is the equal output, and then one is the greater than output. Meaning here that there's a process that is happening where we want to compare the values of the counter with the preset value. And if the value is less than, then we expect this lamp to be energized. If the values are equal, then this lamp is energized. And if the values are the value is greater than, then this lamp is energized. Now, what are we comparing? Look at the data comparison instructions. We have the less than here. So we have a source and another source, because I told you for comparisons, we don't have a source and destination. That one is for data transfer. Here we want to compare. So you're comparing from point a source A and a source B. So again, when you're labeling them, don't forget that for the data comparison instructions, usually we don't have a source and a destination. We have a source A and a source B because we are doing a data comparison. So you're comparing one-on-one. So they both must be sources. So, but notice source A is the accumulator value of the counter, and source B is the value 10. All right. They're the equal one. Again, it's the accumulated value and a source B that has been set at a value of 20. The accumulator value plus another value that is set as 30. So therefore, let us see how this works. This is a very, very simple but very interesting diagram, because what you can see is there we will be having a process where either products are passing on the conveyor belt, just like we had in the previous case, sorry. sorry guys, like in the previous case where you had your conveyor belt with some product passing. But you want to know at certain intervals if the product has reached a certain value, when that product is equal to a certain value, or when the products around the conveyor belt have exceeded a certain value. So let's say you're passing loaves of bread. So you're counting them actually. That's why we have a counter here. Now, the preset value is 50. You can see that the preset value is 50. So let's say that one crate of bread needs to carry 50 loaves. But what we are doing here is at every instance of the count, we are keeping records. So for example, you can see here that the moment that you activate the counter, that is, if I engage this switch, then I'm going to have a logic 1 and I energize my counter. Remember, the counter has a preset value, so it does not have to wait for any other instruction. Unlike the previous case where the preset value was 0, here it does not have to wait. As soon as it knows the preset value, it starts its count. So the accumulator value starts 1, 2, 3. But remember that usually the done bit is when the preset value equals the accumulated value. That's when the done bit is engaged. But let's see what's happening in this case. In this case, we are engaging the moment the counter is already counting. We have a less than input instruction, which is a data comparison. It is comparing the value of the accumulator with another source B. So while the counter just is counting, we have other processes that are happening simultaneously. While the counter is counting, as long as the accumulated value is less than 10, because remember, we are comparing the accumulated value with 10. So as long as the accumulated value is less than 10, then the output here is energized. So this lamp will be on, or it will be energized. Meaning, as soon as the counter starts counting, as soon as we get the value 1, the lamp is already on. Then it moves to value 2, the lamp is still on. Only this lamp, only the first lamp. Move to value 3, the lamp is still on. 4, 5, 6, 7, 8, 9, the lamp is on. But now remember, the moment it hits 10, then this instruction is not true, meaning source A 10, because it will be saying 10 is less than 10, which is not true. So therefore this goes to logic 0. So this lamp will go off as soon as this value reaches 10. The lamp would go off. Why? Because you cannot say, because remember, source A is less than source B. Source A has reached 10, and then source B is also 10. So because this is not true, source A is not less than source 10. That is for value 10. Therefore, the lamp would go off because that comparison is not true. Okay, so that is what happens. It means that the first lamp will be on when we have a count of 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the ones that will ensure that we have this output here being equal to 1. The moment that it hits 10, then it goes back to 0. So the lamp goes off. Okay. Then the process continues. Remember, the loaves are still passing through the conveyor belt. So when this light is on, you know that my loaves are still less than 10. That is definitely the instruction. It doesn't have to be loaves. Whatever it is that you are passing in your production line, you know that when this light is always on, then I know that my products are less than 10. So maybe it takes a while for them to be processed. So, but you know that they're still less than 10. Then, because the counter continues to count, nothing stops it. Nothing stops it. The equal and these other comparisons happen simultaneously. So you can look at the second one. So this one has gone off. The second one is still comparing the accumulated value and source B, which is 20. So This one will only come on when the accumulated value here reaches 20. Because when the accumulated value reaches 20, then this comparison is true. So this lamp only comes on when you have 20 products. You've reached 20 products. Here you have less than 10 products, less than, not equal to, less than 10 products. But here you have it when you have exactly 20 products. And then you can see the greater than is greater than 30. So A is greater than 30, meaning when you have products from 31 all the way from 31, then this will be on. So you'll know definitely that when this lamp is on, I have less than 10 products. That's less than. It could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. But here I know that I have exactly 20 products on the production line. But here I know I have more than 31, I mean more than 30 products. So 31 and above. Okay. And now remember, if you press the reset button, then this guy here activates the reset for the counter, and the counter accumulated value goes back to 0. Okay, so this is only used to trigger the outputs. If they're lamps or whatever it is, they are triggered at certain values of the counter. So the counter will just be running seamlessly. It will not, the counter is not being controlled by any of this. These are inputs. So notice they're not affecting the counter in any way. They're just input instructions that we are using, but based on the accumulated values of the counter. So we are actually taking instructions, or we are taking values of the counter, the accumulated values of the counter, to help us form our input instructions that then provide a desired output. So we take the values of the counter, use them in our input instructions to achieve a desired output. That's what is happening here. And that is, again, how we can use these data comparison instructions. They're also very, very important. You can see how they can be very, very helpful. So you can know where you are, even in your production line. You can know that our production has still not met the expectations or specifications, or we can know that it has met a certain threshold that we need, or we know that it has exceeded a certain threshold that we expected. So again, you can always program that and see how it works. So this is basically how you can interpret. These are very simple, especially once you know ladder diagrams and you know how to construct ladder diagrams using timers and using counters and using latching circuits and using set and reset instructions. When it comes to these data comparisons, they become very, very easy because you can use them as you wish, and they're easy to interpret. They don't have anything complex. Please just remember this. Data transfer, data manipulation consists of two areas. There's data transfer, and there's also the logical operations where we are doing the data comparison. Data transfer, move, must move, and so on, those ones are output instructions. Data comparisons, greater than, less than, equal to, limits, those ones are input instructions. So you need to know how they work. I think I put this in your notes so that you see how limits work, because for limits, you don't have source A and source B. Sorry, I've even moved so far away from this. So for limits, I don't have source A and source B. For limits, you must have a lower limit. This is program control instructions. You have lower limits and you have upper limits. So that's what I expect you to do, that you have lower limits and upper limits. So for and I think it is in your notes, for testing the limits, because for limits there's usually just having a lower limit and an upper limit. So you check whether your value is less than the lower limit, or between the lower and the upper limit, or above the upper limit, because there are boundaries, basically boundaries. I'm trying to scroll down there again and I don't see it anymore. We have done that. Yes, this is the guy. So you can see there are three values here. Please note, for limits, and I'm going to test you on this. You've got a lower limit, but there's the test value, and then you've got the higher limit. So the lower limit has been set at 25. It has its own address. Please note that as well. It is N722. Now, it doesn't have to be N7. You can even call your test B4 0. That, as long as you give it a different address, because I'm not testing exact manufacturer addressing system, then the test value is also in a different location, and that is assigned with the value 48. And then, of course, you've got the high value, the higher limit, again assigned a different address and given a certain value. So you need to test. So here for the limit, if the value, in this case, let's see, if the value, which is 48, falls between 25 and 50, then the lamp is supposed to go on. So that, because that's true. Remember, the value is 48. You can even write it down mathematically for you to quickly relate. The value, the test the lower limit is 25. The upper limit is 50. So you just check, is 48 greater than 25? And less than, I don't know how I've written this. Is 48 between 25 and 50? Is it greater than 25 and less than 50? That's what I should write. Okay. Is it? It's been long since I did math. Okay. So if 28 falls between 48 falls between 25 and 50, then the pilot lamp goes on because it's within the limit of the lower limit and the higher limit. But if it is outside that limit, so if the value was maybe 60, we know that it doesn't fall within this limit, so the lamp would be off and stuff like that. Okay. Or if the value here was something like 12, again, that is falling outside the limit because 12 would be on that side, 60 would be on that side, 48 is right in between those two values. So that's again how the limit works. It's a very, very simple setup where you're simply trying to compare a value within a higher limit and a lower limit. So if it falls within the limit, then you have the output energized, or the output is activated to logic 1, but any other instruction is false. That is, any other comparison or any other limit gives you a logic 0. Okay. From this place here. Yeah, so because of time, ladies and gentlemen, I think I will stop here. I just want to indicate to you guys that I am going to send this class the cut. We're going to send him the CAT. Now, please attend explicit instructions at the end of that CAT. Please follow those instructions. Physical in our class on Wednesday next week. Physical report or your answers. So carry your scripts to class. We are going to have a physical class on Wednesday next week where I will collect all those scripts. We'll have a class on Monday. We'll start a new topic. But on Wednesday next week, we'll have a class as well. And I will collect all from each student. Don't carry for any other student. I will collect and sign off for each student. So you're expected to have your own report. You draw your own ladder diagram. You can go simulate them. I don't have a problem. You can go simulate and test whether it works or not. But even once you have simulated, please draw the ladder diagram. And I'm not taking in PDF now. I'm not taking in any soft copies. I'm taking physical copies of your CAT answers. So I'll need those answer sheets from each one of you in the next class. And I will not be collecting for you. Not please don't bring for a colleague. Each person is going to sign for their own script because this is like a CAT. It's only that I've allowed you to go home with it. But when you're submitting it, each person must submit their own CAT and sign off that they have submitted before I mark, just to ensure that nobody's will say, oh, copied for me and then just submitted. I want everybody to own up to their work so that if they are found having copied each other, they don't have to blame anyone. So please take note, get the CAT from your CR immediately after this and ensure that you take time and do that CAT. And if possible, simulate it, make sure that it works, because then it makes your work easier. You are sure that you'll have 30 or out of 30. If it works. If it doesn't work, then you know that there's a problem. And then I'll have a look at each one of them. So even if you simulate them, please don't scan, do what? No. Draw for me a ladder diagram and submit the work as indicated in the instructions that will be underneath the CAT. So that marks the end of my time. So next week, ladies and gentlemen, we begin on the last topic, which is program control instructions, where we look at other things like jump instructions and the like. So any questions, please, before we end the class? Soba, go on.
Could you send the textbook?
Yeah, I can, but I think I had sent this text to you guys. You guys already have a copy of this. I'm sure this is what you should be sharing in your WhatsApp groups. But if you don't have it, then maybe I'll send a copy as well to the class rep so that he can share again with you guys. It's quite voluminous, so you really need. Maybe I think that's why it's on my Google Drive. So maybe you request for it from my Google Drive, and then I share it with you because it's quite voluminous. I can't attach it as mail. So you'll have to request it from my Google Drive, and I'll grant you access so you can download it. All right, any other question?
Yes. So in the second example, what was the function of the limiter switch? The one with the ABC.
The second example?
Yeah.
You're asking what is the function of the what?
Limiter switch.
LS1. Oh, the limit switch. Okay, now I remember what you're talking about. Okay. Here we are. Before you get logged off, where is it now? Now it has decided to disappear on me again. The limit switch. I think it's the second example we did. Yes, here we are. Okay. So you can see here that the limit switch is just used to energize the counter. Because you can see this, unless I don't understand your question, but this is to energize the counter. And then of course these others are just to connect A, B, and C. You could even use if you had a different way, you could even use a select switch, a 3-position select switch for each of these so that you don't have to have 3 switches. You could still use that if you had a select switch. So you'll notice that some of these switches, it's just based on your preference or on how you want your setup to be. So here I could use one select switch, but it's a 3-position select switch. Or in this case, you have 3 different switches, and then you have one. Again, in fact, I don't think there's harm on using any other switch other than a limit switch. This is just an example provided, but you could use any other switch here because it's not providing a unique functionality in this case. It's just to energize the counter. And so you can use any other switch to do that. Okay. In this case, I think just for illustration purposes, they try to use as many different types of switches as possible so that you understand. They mentioned several devices. So you need to know what are some of the switches that can be used at the input. You have a limit switch, there's a push button, you have I don't know, the solenoid valves, and so on and so forth. So I don't think the limit switch has a unique function here. Sawa.
Yes.
All right. So let me stop sharing again, see if there are any hands. I don't see any hands. Maybe I quickly check the comment section. I don't see any comments. So, okay. Yes. What is the default output of the selector switch when it is neither connected to 5 volts nor 0 volts? Hey, you guys are sophisticated, even in your questions. Wow. What is the default output of the selector switch when it is neither connected to 5 volts nor 0 volts? This is from Ochor Samuel. Now, the selector switch is a 2-position switch. So it can either be in one of 2 positions. The selector switch that we indicated there is a 2-position switch. So it's like having an on-off switch. So one position controls a certain set of rang, then one rang, and the other position controls another rang. So you cannot have it in another position that is neither 5 nor 0. It's a 2-selector. 2-selector. You know, if it were 3-selector, then now we would have issues there. So you have to decide which one is for what rang. But this is a 2-selector switch. You can only turn it in 2 positions, on, off, and something like that. Okay. So 2 positions, it doesn't mean there is off and then there is 1, 2. No. 2 position meaning it's either 0 or a 1. Okay, on or an off. So that is it. I hope you answered, Samuel. Any other question? That's the only question I see on the chat. All right, ladies and gentlemen, I wish you well. Please take my card seriously if you want to score well, and then we do our last topic. We prepare for your examinations. All right, so you have a good day. Thank you very much, and see you guys on Monday.